Bismillahirrahmanirrahim. Assalamu alaikum. Okay, this video is about modulation and demodulation. तो I think this was a file जो सर ने अपलोड की थी for practice and इस तरह का question quiz में भी आया था ना एक दफ़ा. तो for that I need to first explain कि हो क्या रहा है ना यहाँ पे, what even is this signal over here ना. तो usually when we see signals, right, we see them like this. It's usually just a combination of sine waves of certain frequencies just added together. So let's say you have a sine wave of frequency like 1 kilohertz, right? So in the time domain it's gonna look like this. Like when you transfer it in, you take a Fourier transform, it's gonna be converted into the frequency domain, और उसमें जाके ना it's gonna be like this के there's gonna be a peak, there's gonna be an impulse at 1 kilohertz and -1 kilohertz, ठीक है, and then -1 यहाँ पे भी ना. तो this is what you call a spectrum, ठीक है, and it's when you convert a signal from the time domain to the frequency domain, ठीक है. Like you can see. अच्छा, इसने like इसका फ़ायदा क्या है ना. Let's say you have इसका ना let's say noise cancellation ना. Noise cancellation में Fourier transform यूज़ होता है. It's a practical examples. AirPods वगैरह उनमें होती है ना active noise cancellation, you call it ANC. तो ये it's possible because of Fourier transform ना. तो what basically happens is कि the mic picks up like noise. उसमें ना लोगों की आवाज़ें भी होती हैं, like normal noise जो human voice है ना, इस तरह करके, ठीक है. and then let's say कि there's like a car passing by or a horn or just some random noise ना जो बहुत ऊंची सी है ना. it's gonna be like over here, like it's gonna mess up the signal, right? तो when you look at it in the time domain, like इस तरह का सिग्नल है ना, इधर भी ह्यूमन वॉइस है और इधर साथ में पीछे वो भी होगा, द कार पासिंग बाय. तो इट्स जस्ट ऑल मिक्सड अप टुगेदर. तो यू डोंट नो विच पार्ट ऑफ इट इज़ द ह्यूमन वॉइस एंड विच पार्ट ऑफ इट इज़ द बैकग्राउंड नॉइज ना. तो लेट्स से कि द ह्यूमन वॉइस typically lies around, it's just I'm assuming it, I don't know what the actual values are. It lies in the range of 4 kilohertz to 6 kilohertz, and the rest is just background noise ना. तो let's say you have a signal and it looks like this ना. ठीक है, इसके अंदर ह्यूमन वॉइस भी है, इसके अंदर बैकग्राउंड नॉइस भी है. तो व्हेन यू कन्वर्ट इट इनटू द फ्रीक्वेंसी डोमेन, यू गोना सी के देयर इज गोना बी पीक्स at 2 kilohertz, 3 kilohertz, and there's going to be a peak at 5 kilohertz and maybe a peak at 9 kilohertz, ठीक है. तो because you know कि the human voice lies over here, or you're going to look at the peaks and you're going to know कि oh, this is the range in which the human voice lies. So this is the component which we need to maintain, which we need to keep, and the rest is just background noise. So you can like remove the background noise. So that's how noise cancellation works. Noise cancellation means it's like you remove all of the voices. Lekin if you want to extract a human voice, you can do so by extracting the component. Like इस तरह करके ना you can analyze a signal in detail ना. It's really like useful. तो अच्छा, coming back to this question now, before you're able to solve this numerical, you need to know how demodulation and modulation works. You have a signal in the frequency domain, like यहाँ पे represent हुआ frequency domain, and you multiply it with the carrier frequency. तो the carrier frequency over here is like 10,000 t, and t is just here. इस तरह करके होता है, रुको, it's actually 2 pi f. तो to get the frequency you just look at this number and divide by 2. तो असल में जो frequency होगी ना सिग्नल की, it's gonna be 5,000, and when you multiply a signal by a carrier frequency, what happens to the signal is कि it gets like repeated. अभी जैसा ये वाला सिग्नल है ना, it's like this. वो बहुत बड़ा है, एक सेकंड. It's like this. This is 5000 and this is minus 5000. And when it gets like multiplied by a carrier frequency, it's gonna be repeated at the frequency of the carrier. What that means is कि यहाँ पे हमें पता है ना कि frequency carrier की 5000 थी ना, तो जो point यहाँ पे 0 पे था ना, वो point shift होके चला जाएगा 5000 पे. तो अब जिस तरह ये point 0 पे था ना, तो अब ये point आ जाएगा 5000 पे. तो यहाँ पे let's say it's 5k. तो यहाँ पे अब ये peak आ रही होगी, ये वाली. It's gonna, अब you know कि this was 5k, तो you're just gonna like do the math, and this is gonna be 10k, and this is going to be 0. And the same thing is gonna happen on the positive side as well. It's gonna get repeated at positive 5k. This was negative 5k. Okay, it's gonna get repeated at positive 5k in the same way. यहाँ पे 10k आ रहा होगा, and that's like your carrier frequency वाला signal ना. And like यहाँ पे question में भी लिखा है ना, for the system shown, draw shown in the figure, to draw the signal spectrum at points A and B. So at point A, after this gets multiplied by the carrier frequency, this is going to be the answer ना. इसके बाद इसके साथ ना ये add हो रहा है, summation हो रही है ना. तो once this is being added ना, तो it's gonna look like let's say इसके अंदर अभी ये add हो रहा है ना, this signal. तो the resultant is going to be like this, यूं ठीक है, and that's gonna be multiplied by another frequency, and that's gonna get repeated again. तो ये सारी चीज़ अब जो 0.0 पे था ना, it's gonna be at 10,000 now क्योंकि it's 20,000 t. And one इस तरह करके repeat होता है. I'm gonna like simulate this thing in MATLAB so it makes more sense. So I have MATLAB open already, so I'm gonna do this in Simulink. यहाँ पे I'm just gonna make a simple like sine. I'm just gonna make a simple sine wave. Here it is. इसकी frequency रखते हैं 2. इसकी frequency 1 kilohertz रखनी है, 2 pi 1000. Okay, and इसके बाद I need a scope. And I need a spectrum analyzer. What this is कि हम वो Fourier transform लगा के देखते नहीं हैं. This one, the DSP system toolbox. अच्छा, we see the signal in the frequency domain. This is what this is for. It's gonna show us the signal in the frequency domain, and it's gonna make sense. ये simple sine wave है 1 kilohertz की, and I'm gonna connect it to the spectrum analyzer as well. Once I run this, we're gonna see peaks at like we're not seeing peaks to go. Let me just see कि इसकी sampling क्या है. Sampling time इसका कम है काफ़ी. It needs to be 1e minus 5. Let me just run this again. Okay, अब इसका sampling time सही है. पहले sampling time कम था ना, तो the resolution of the signal was wrong. अच्छा, as you can see कि there are like 2 big peaks at 1 and minus 1. ठीक है, this is what we'll see like if you have a signal of 1 kilohertz. Scope पे भी दिखा देता हूँ. It's a simple sine wave. This is like zoomed out. Let me just zoom in. So when you have a signal, any signal, and you look at it after applying the Fourier transform, we're going to see the frequency components. इसके अंदर अभी खाली एक ही sine wave थी ना, that's why we only saw one peak. So if I add like a carrier frequency to it, so you're gonna see the peaks at the carrier frequency as well. So for that I'm just gonna be using another sine wave, like in the carrier frequency is going to be this is 10,000. This is high, this is like really high, you don't need it to be this high, बहुत ज़्यादा है. Let me just change it to 4,000. Okay, apply. Okay, and I'm gonna multiply it with this so I'm multiplying it with this, and now I'm gonna look at it over here as well. Now if I run it, अच्छा you can see कि ना पहले this was the signal before, and this is the signal after it has been multiplied, and we multiplied it at with the frequency of 4k, right? ये देखो, it repeated at -4 and +4. The same way these signals are being repeated 5k की frequency के साथ जब हमने multiply किया ना, the signal shifted to -5k and +5k. इसी तरह this was the original signal before it was multiplied with the carrier frequency, and after it was multiplied with the carrier frequency, it shifted. Right now it's at 0, and the point which was at 0 has moved to the frequency which is 4 kilohertz, -4 kilohertz and +4 kilohertz. That's what happens when you multiply a signal with the carrier frequency. So it's super simple. Achha, when you're like demodulating a signal, you need to multiply it with the carrier's frequency again, and you'll get the original signal back. That's how demodulation happens. Like this is just modulating, so we're gonna say कि ये हमारा modulated signal बाहर जा रहा है ना, तो if we multiply it with the carrier frequency again, it's gonna give us the original signal back. Oh रुको, I just deleted Control-C. And what that does is कि let me just show you. Why isn't this working? Oh my god, रुको. How do I connect this? So इसको मैं delete करूँ. Let me just start like this. There you go, हो गया. अच्छा, now you see that this is the same 4 kilohertz frequency, and when I'll multiply it again to the like modulated signal, it's gonna give the original signal back. मतलब जो यहाँ पे signal था ना, वही हमें यहाँ पे मिलेगा. तो if you run it, अच्छा, there you go. अब you can see कि ना सबसे पहले this over here is our original signal, ठीक है, and you can see it has peaks at 1 kilohertz, जो हमारी sine wave थी ना, it has peaks at 1 and -1, and after it was multiplied with the carrier frequency of 4 kilohertz, it has it's been like copied and pasted at like 4, or जो 0 पे था, it shifted, right? And then after you multiply it with the carrier frequency again, you can see कि ना जो peaks थी ना आपके पास, they're back at 1 and -1, just like the original signal ना. तो this doesn't these extra peaks are here, right? इनको क्या करना है, you pass it by a low pass filter. तो उससे होता है कि जो 0 के आसपास वाली frequency थी वो pass हो जाती है, means कि जो these extra peaks are just gonna get like removed, and you'll have the original signal back. So that's how modulation and demodulation works in the double modulated double जो DBS जो भी है in this DSP, double sideband signal modulation. That's if you look at this, right, यहाँ पे हमारा सिग्नल आ रहा था, ठीक है, it was being multiplied with a carrier frequency of 2 cos 10,000 t. That means it was being repeated at minus 10,000, minus 5,000 and plus 5,000, and after that happened, it was being added with this signal over here. It was being added with this signal over here. अच्छा, यहाँ से भी ज़रा सा ऊपर होगा, like it's gonna be, क्योंकि ये चीज़ें भी, these values are also being added. It's gonna be like यूं smooth सा. It's gonna be like this. Let me just use a different color so it's visible. ठीक है, it's gonna be like this. जब जो दूसरा सिग्नल जब ऐड हो रहा है, it's gonna look like this. And when it's being multiplied with this carrier frequency, which is 20,000, it's gonna get mirrored again. So let me just draw that. Yeah, ठीक है, this is gonna be 20,000 minus 20,000. This is 0. This is plus 20,000 kilohertz. इसको अगर हम ड्रॉ करेंगे, it's gonna be like this. यूं, this is at minus 15 kilohertz. It goes down like this. यूं, at this is 10 minus 10k. यूं जाता है ऊपर, it goes down like this, and this is again like it's mirrored. So यूं at 10k, this is the peaks are gonna be at 15 and 5 and 20. So this is 15, this is 10, this is 5, this is minus 5. This is what's happening. तो जो हमारा आंसर होगा ना, see, this is what we need to draw. This sketch basically, this is what we need to do. That's how signals are modulated and demodulated. And if you have like a proper understanding के modulation demodulation क्या होती है, it's gonna be easier to do this one. I'll upload this solution soon. Okay, love.